Hey guys, so today we get to learn about balancing equations, and this is kind of an extension of the law of conservation of mass. So that's why we talked about that first last time, and this time it's going to be balancing equations. So before we jump right into it, just a couple of vocabulary words that you need to know that I'm going to be using. So I'm going to write out the formula for a compound. So one of the vocabulary words you need to know is coefficient. So this big number right here in front of the formula for the compound, that is called a coefficient. So any number in front of the compound, that's the coefficient. Just like in math, you can have a number in front of a variable, it's a coefficient. Same thing here. This little number that's kind of to the right and below the oxygen here, that is called a subscript. So I'm going to be talking about those as we go through this video, so you just need to understand what those are. Okay, so with that out of the way, let me write down a chemical equation, and we're going to talk about why it needs to be balanced and how we do that. So this is a really simple equation. It's going to be H2 plus Cl2 makes HCl. And you should be taking notes along with me here on page 92. So this is something a lot of you have noticed and asked questions about. You've noticed that, for example, in this equation, there's two H's on the left over here, but there's only one H over here on the right. And same thing with the chlorines. So right now, the way this is written, this disobeys the law of conservation of mass, because the law of conservation of mass says that atoms can't be created or destroyed in a reaction. And right here, it looks like an H and a Cl are just disappearing. But that can't be what is happening. So we have to balance this equation to make it true, to make it obey the law of conservation of mass. So there's a couple of things you want to remember when you're balancing an equation. So we're going to write a couple of them up here. So we're just going to write rules / tips for balancing. Okay, and this first one is a rule. This is not a tip. This is a rule. You can only change coefficients. Okay, so to balance this equation, we can add coefficients in front of any of these molecules. And remember, the coefficients are the big numbers. But what we cannot do is add subscripts. So when a lot of people see this, the first thing they want to do is like go in here and add 2's. That changes the identity of this compound. That makes this a totally different thing. In this case, it's actually something that doesn't even exist. So we can't do that. But what we can do is put big numbers in front of any of these molecules. All right, so before we start doing that, I'm going to show you a really formal way to balance equations. This way will always work. I recommend that you do it on your homework. I recommend that you write things out. So this is how it works. Right where the arrow is, underneath the arrow, you're going to draw a straight vertical line. So everyone do this with me. I highly recommend that when you balance equations, you do it in pencil, because it does involve a little bit of trial and error, so you're going to be erasing things. I love to use pen. I always write in pen, but this is one time where I'm going to use pencil. So, highly recommended. Okay, so on the left of this vertical line, we're going to write down every single element that appears on the left side of the equation. So we've got H and Cl. And then, since this is going to obey the law of conservation of mass, we have to have those same two elements on the right. And I highly recommend writing them in the same order so you can compare them more easily. So what we're doing here is we're going to just keep track of how many of each element we have on each side, and we're going to change things until everything's balanced. So on the left, I have 2 hydrogens, because there's a little subscript 2 there. And I also have 2 chlorines because of the subscript 2. Okay, now let's look at the right. On the right, I have 1 hydrogen and 1 chlorine. There's no subscripts, so that means there's just 1. So my goal in balancing is to make it so the hydrogen numbers are equal and the chlorine numbers are equal. And I can only add coefficients. So a lot of you can probably see that what I need to do here is add a coefficient 2 in front of the HCl. Now, as soon as I add that coefficient 2 down here, I'm going to change everything that coefficient changed. And the way coefficients work is that they multiply to everything after them. So the 2 multiplies to the H, and it multiplies to the Cl. Now, I don't want you to think about it multiplying to this number down here. Ignore this number, just cross it out. Just think of it multiplying to like the H in the formula. So there's 2 H's because there's a 2 there, there's 2 Cl's because there's a 2 there. Okay, and now we can see our H's are equal and our Cl's are equal. So this equation is balanced. So this is the answer right here. There's no coefficients in front of these two, and there's just a 2 in front of that. Okay, we're going to do a couple more examples. We're going to do this equation, CH4 plus O2 makes CO2 plus H2O. You might recognize this as a combustion reaction because it is something reacting with oxygen to produce carbon dioxide and water. That's what combustion is. Before we balance this one, I want to give you a tip. This one is just a tip. Highly recommend it though. Whenever you have hydrogen and oxygen in your equation, you should always balance them last. It's just going to work out better if you do that. Always balance hydrogen and oxygen last. And in that order, you want to balance everything and then hydrogen and then oxygen. The reason for that is because oxygen often ends up in more than one compound. Like see how it's here and here? So if you try to balance it at the beginning, it'll like mess everything else up. And often if you wait till the end, it'll just kind of work itself out. So let's draw our vertical line. Let's write down all the elements that we have. We have C, H, and O. On both sides, again, write them in the same order. We've got 1 carbon, 4 hydrogens, 2 oxygens. 1 carbon, 2 hydrogens, and you have to be careful here because there's 2 oxygens right here and 1 right here, so that makes 3. Okay, so we can see our carbons are already equal, but our hydrogens and our oxygens are not. So let's do the hydrogen first, because that's what is recommended. So to make this hydrogen become 4, we're going to put a 2 right here, because 2 times 2 right here is going to be 4. Now, this also changes my oxygen though, right? Because it makes it so there's 2 oxygens right here, plus the 2 right here. So this also becomes 4. Again, notice I'm not multiplying this number. I'm just crossing this number out and just recalculating my oxygens. Okay, so my carbons are good, my hydrogens are good. I now just need to fix my oxygen over here. And I can do that by putting a 2 right there. 2 times 2 is 4. And it's balanced. So not too bad. You'll notice often that you're going to get pretty low numbers for your coefficients. Sometimes you can get higher. Sometimes you can get like 4, 5, and 6. But if you're getting like 17 or something, you probably, most likely, need to try something else. The coefficients aren't usually going to be very high. All right, so another example now. This one is going to be a little bit more involved. We're going to have aluminum nitrate and sodium hydroxide reacting to form aluminum hydroxide and sodium nitrate. You might notice, hopefully, that this is a double replacement reaction because the OH and the NO3 switch places. Okay, so there's lots of different elements on here. I'm going to show you 2 ways to do this problem. There's kind of an easy way and there's a longer way. So I'm going to show you the longer way first. And then I'll show you a way that's easier if you are good at polyatomic ions. If you're not good at polyatomic ions, you're going to want to do it this way that I'm doing it. So, we've got aluminum, nitrogen, oxygen, sodium, and hydrogen. Make sure that you always, again, write these in the same order on the right, because that really is just going to make your life way easier. If you write them in a different order, it's going to be really confusing. Okay, so now we need to go through and count. It's a little tricky here. Aluminum, there's one of those, because that 3 right here does not apply to the aluminum. Now the nitrogen, the 3 distributes in, remember? So that makes it so there's 3 nitrogens. And then the 3 here, this 3 subscript, multiplies by this 3 subscript to make 9. So there's 9 oxygens right here, plus there's 1 right here. So you can't forget this oxygen. So 9 plus 1 is actually 10. Then there's 1 Na and 1 H. Okay, and then over here, we've got 1 aluminum, 1 nitrogen. I've got, if I distribute this 3 in, 3 oxygens, plus another 3 over here, so 6, 1 Na, and 3 H's. Okay, so lots of things going on here. Again, I want to balance oxygen and hydrogen last, so let's start with N. So I've got 3 N's over here. What can I do to make there be 3 over here? Well, I can put a 3 right here. And that now changes a bunch of things. It's going to change, first of all, my sodium. So I'm going to cross out my sodium, recalculate it, I now have 3. I'm going to cross out my N, I now have 3 of those. And I'm going to cross out my O. Again, notice I'm not multiplying this number, just crossing it out. I've got 3 times 3 oxygens right here, which is going to be 9. So the coefficient multiplies by the subscript. Plus another 3 oxygens over here. So now I've got 12. Okay, so now my oxygens are still not balanced, my hydrogens aren't. Let's do sodium now. So if I want to make this sodium become 3, put a 3 right here. And now I've got 3 Na. My oxygens, I've got 9 right here, plus 3 right here. So that's going to be 12. Oh, and notice, look, they're balanced. And now my hydrogens are 3. So now it's balanced. So that seemed like a lot of work to just figure out that there's a 3 here and a 3 there. But that's all it is, just 2 3s. Now let me show you the easier way to do this. The easier way is if you notice that there's some polyatomic ions here, you can actually treat those as kind of like one element. So I could go Al, NO3, Na, OH. And again, this only works for polyatomic ions. You don't want to group elements together otherwise. But if you look, I've got 1 of those 3 nitrates, 1 sodium, and 1 OH. This is like before I've balanced it, if I'm doing this before I balanced it. 1 aluminum, 1 NO3, 1 Na, and 3 OHs. So it makes it really easy to see. To balance my OHs, I just put a 3 here. And to balance my Na, NO3, I just put a 3 here. Okay, a lot simpler, a lot more streamlined if you do that. So, if you're good at noticing polyatomic ions, highly recommend treating them as one unit. But if not, you can do it the long way and that's fine too. One last thing I just want to mention. You might get questions on Canvas that look like this. This says, when the following equation is balanced, what is the coefficient in front of HCl? And then let's say here's our equation. Oops. Okay, so this question is asking me for the coefficient in front of HCl. I have to balance the whole equation to figure that out. I hope that makes sense to you guys. I hope you understand that. If you get a question like this on Canvas, you can't just like figure out one coefficient without figuring out the others. So this is a good example to show too. So I'm going to just really quickly do this example for you, and then this will be the last thing. Sorry, this video is a bit long. This is just a concept that takes a bit to explain. So got aluminum, HCl, same thing over here. I've got just 1 of each on this side, and then kind of strangely on this side I've got 3 Cl's and 2 H's. So this gets a little bit tricky because the first thing that I feel like I want to do is balance the Cl So I put a 3 here, but then that makes my H3, and it's 2 over here, so that's not gonna work. So you have to sometimes do a little bit of trial and error with balancing. And so in this case, I can try a few things. I notice that I've got 3s and 2s, so that usually means I'm gonna need to be thinking about like common multiples, like 6. So what if I maybe put a 3 in front of this hydrogen right here? And that would make me have 6. 3 times 2 is 6 hydrogens. And then if I wanted to have 6 hydrogens over here, I'd have to have 6, and that would give me 6 chlorines as well. And then to have 6 chlorines over here, I'd have to put a 2 right there. That would give me 2 aluminums, 6 chlorines. Then I'd put a 2 right there for 2 aluminums. So these are the coefficients for this equation. So the answer is going to be 6 to that question on Canvas. So just so you know, if it asks this question like that, you got to solve the whole thing. You can't just like do part of it. Balanced equation. I also highly recommend that when you're doing this, that you write out the equations when you're balancing them. Don't try and do it in your head. That's a good way to mess up and miss things. So just highly recommend write it out. You guys can do this. If you need help, I'm totally willing to talk with you during my office hours, my virtual office hours, which are posted on Canvas, or you can email me. There is a way to get help if you're a little bit confused about this. But hopefully as you practice and try it, it'll make sense. So good luck, and hope you're having a good week.